Waving at you from West Virginia. Clearly I am not in West Virginia, but I think you know that I've got joke of the day, and I think you know where joke of the day is going. So why did Noah not do much fishing on the ark? Why? I mean, he's on the ark, he's surrounded by water. Why did he not do much fishing? Well, because he only had 2 worms. Because there was only 2 by 2 by 2 animals on the ark. Okay, well, we're going to look at some applications for adding and subtracting sign numbers in your algebraic expressions. We now know how to add sign numbers, and we know that when the signs are the same, we're going to keep that sign. We're just going to add up the digits. We know that when the signs are different, we're going to take the smaller digit from the larger digit. We're going to take the sign of the larger digit, because what we've been doing is ignoring those signs. When the signs are different, we're going to ignore the signs and take smaller digit from larger digit, and then still kind of sort of ignoring the signs, but take that larger digit, take its sign because it overpowers. Now with subtracting our sign numbers, remember, we know those addition rules. We're very good at those addition rules. So let's kick it back into an addition problem. And the way we're going to do that is we're going to add the opposite of the second one. Kicks it back to an addition problem. We go back to those rules of when the signs are the same and when the signs are different. So now let's see, okay, when we throw variables into the mix, what happens? Well, this is the idea of combining up like terms. Remember, how do you recognize like terms? They have the same variables, and those variables are to the same power. Same variables, those variables to the same power. Now, we're not going to see different powers in these examples, but most definitely we will see different variables. So once we recognize that we have like terms and we want to combine up those like terms, we're going to keep those like variables because that's what's making them alike is the variables, and we're going to do what I call working the coefficients. And what that means is we're going to add or subtract those coefficients. Now, that goes back to our rules for sign numbers. The rules for adding and subtracting those sign numbers, that's what we use to combine those coefficients. So let's take a look at these examples. First example says I have 107x plus negative 40x. So those are like terms because they both have an x. So what we're going to do is we're going to keep that x, that's what's making them alike, and we're going to work the coefficients. So we're going to say we're going to take that 107 and we're going to add a negative 40. Well, adding sign numbers means ignore the digits because these signs are different. So we're going to not ignore the digits, we're going to ignore the signs. And we're going to take smaller from larger. So 40 from 107 is going to be 67. And we're going to take the sign of a larger digit. Ignoring the signs, the 107 is larger. So we'll take its sign because it overpowers this one. And so that's how we end up with a 67x as our answer for that one. Now take a look at this one. We have several variables in there. We have a 3m, a negative 15n, a negative 11n, and a 6m. So we're going to combine up the 3m and the 6m. We're going to put those two together. When we combine a 3m and a 6m, basically, now remember, the sign in front's the sign that goes. That is a name tag that you put on your front. When you go to a meeting, you put that name tag on the front so that I know who you are. If you put your name tag on the back, I have no idea who you are. Name tag goes on the front so that I can identify your face with your name, and you do not take that name tag off until you leave the room. So sign in front's the sign that goes. This is a positive 3m and a positive 6m. So I'm going to put those two together like so. And when I do, 3m and 6m will give me a 9m. Now, where are the other like terms? Well, I've got a negative 15n. Remember, sign in front's the sign that goes. There's the name tag, negative 15n minus 11n. So I'm going to put those two together, and I'm going to add in that negative 15n minus the 11n. And remember, I'm going to turn this into an addition problem because I'm going to add the opposite here. So I'm going to add a negative 11n. And so now that it's an addition problem, I'm going to look at it and say, whoa, signs are the same. When the signs are the same, I'm going to keep that sign, and I'm going to combine up those digits. A 15 and 11 will give me a 26, so I have a 26n. So my answer is a 9m minus 26m. Now, I could look at it instead as a 9m plus a negative 26m because they mean the same thing. Because remember, if I was to turn this one into an addition problem, what I would do is I would add the opposite of the second one, and when I add the opposite, it'll turn it into plus a negative 26. So therefore, these two are the same. Now take a look at this one. Once again, I'm going to combine up like terms. I have a 20y here minus a negative 6y. Those are like terms. This negative 9 is a standalone. So when I put these two together, notice what I'm going to do here is, again, I'm going to add the opposite of the second one. So when I do that, and I do add the opposite, I get plus a positive 6y. And now a 20y plus a 6y is going to give me a 26y. And don't forget, we've got that negative 9 that's in the back. So we need to carry that negative 9 down. Carry it down like this. And there's my answer. Those two are not like terms, so I cannot put them together because this one does not have a y. Similarly, back up here, the m and the n, those are not like terms. I cannot put them together because this has an m and this has an n. And once again, like we said up here, I could write it if I really wanted to as a 26y plus a negative 9. But most people don't like to do that. Similarly, most people don't like to do this. They prefer to keep it concise this way and this way because this is just extra writing that isn't necessary. So take a look at this one. So now what we have is many variables, so lots of like terms in here. And so we've got a negative 12x here plus a 12x here. Now, a negative 12x plus 12x, remember, if I'm going to look at this and I'm going to say, well, the signs are different. This is positive, this is negative. So I'm going to ignore the signs, take smaller from larger. Well, that would be 12 from 12, which is 0. So I'm going to get a 0x here, or I could look at it and say, you know what, they're going to cancel each other out. Now, I also have like terms with my y's right here and right here. So I have a 5y minus a 6y. And just like we said before, we're going to add the opposite of the second one. Currently a positive 6y, so I'm going to add the opposite. And when I do, now go back to those addition rules that say ignore the signs. Notice signs are different. So I'm going to ignore the signs, and I'm going to take smaller from larger. So smaller 5 from larger 6 is a 1. And I'm going to take the sign of the larger digit. The larger digit is a 6. Its sign is negative. It will overpower the positive. So I come up with a negative 1y as my answer. And you know that you don't need to show the 1, so I can leave that out and just call it a negative y. Now, don't forget, I'm not done combining up all my like terms. Aha, this negative 5 here, it won't combine with anything. So I'm just going to carry it down, and there it is. So you can see that when it comes to your algebraic expressions, the idea is to combine up like terms. Keeping the variables that are the same, keep those. And just work the coefficients, going back to your rules for adding and subtracting signed numbers in order to work those coefficients. I hope it helps. Have a great day.